In this lecture, we are going to discuss chapter number 2, Pythagoras Theorem, question 3b, each of 3 marks question. Questions are from question bank provided by Maharashtra State Board. First question we have as shown in the figure, angle DFE. Look at the angle DFE. We have 90 degree. FG is perpendicular on ED. If GD equals to, we have given 8 next to it. FG equals to, we have a 12. Look at the FG, it is equals to 12, and then we have to evaluate the value of EG, next to it value of FD and the value of EF. So what shall we have to do? Look at here. First of all, we have in triangle, I am writing in triangle, we have DEF, the measures of an angle, we have DFE is equal to 90 degree. That means given triangle DEF is a right angle triangle. Is in the right angle triangle we have given FG with a perpendicular hypotenuse, that is DE. So that we can able to use here geometric mean theorem. So as per the geometric mean theorem, now we are having square of FG, that to be equals to now the segment made on hypotenuse, that are we have EG and GD, their product EG into GD, that is equals to we have the FG square. Try to replace by their value. FG value we have a 12, so that 12 square to be equals to, we have to evaluate for EG into GD value we have a 8. So that 12 square is 144, that to be equals to we have now EG into 8. To evaluate the value of EG, try to shift now 8 from RHS to LHS, so that we are getting 144 divided by 8, that is equals to EG. Now 144 divided by 8, we are getting the value of EG, that to be equals to we have 18. So that let's try to substitute 18 on a figure. We have EG to be equals to now the 18. Look at the next one. We have to evaluate for the FD. Look at this red shaded triangle. I am writing now in triangle, supposed to be we are having DGF. In it measures of an angle DGF is equal to 90 degree. That means given triangle is a right angle triangle. So we are writing by Pythagoras theorem. Look at the triangle DGF. We have, as per the Pythagoras theorem, hypotenuse is the DF, so that we are getting DF square to be equals to GD square plus FG square. Look at the values we are getting here. DF square to be equals to GD value is 8, so 8 square, plus FG value we have a 12, so plus 12 square. 8 square we have 64, 12 square we have 144. So that now the value of DF square we have 64 plus 144 becomes 208. Now to evaluate the value of DF, taking square root on both sides, square root of DF square we are getting DF, that is equals to we have square root of 208. We can write 208 as a 16 into 13. Now once we took 16 outside the square root, we have square root of 16 is 4 into root of 13 as it is. So therefore value of DF we have a 4 root of 13. Look at the last sub question. We have to evaluate for the EF now. So EF be the hypotenuse of this blue shaded triangle, we are taking EGF. So that I am writing now in triangle EGF, we have measures of an angle EGF, that is equals to a 90 degree. That means given triangle is a right angle triangle, so that here we can able to apply the Pythagoras theorem. So by Pythagoras theorem we are getting hypotenuse of triangle EGF is EF, so that EF square to be equals to we have the EG square plus the GF square. So now look at the triangle. We have EG value is 18, while FG value we have given a 12. So let's try to replace EG and FG by their value. We are getting EG square to be equals to now EF square, actually hypotenuse is the EF. EF square is equals to now EG is 18. So 18 square plus GF we have a 12. 12 square. We are getting 324 plus 12 square is 144. Sum of them we have 468. So the value of EF square we are getting 468. To evaluate the value of EF, taking square root on both sides, EF squares are square root, we are having EF that is equals to root of 468. Now we can write 468 as a 36 into 13. Once we took 36 outside the square root, that means square root of 36 we are having a 6 into root of 13 as it is. So therefore the value of EF we are getting 16 times root of 13. Look at now the second question from question 3b. A congruent sides of an isosceles right angle triangle is 7 cm. Find its perimeter. Now what is mean by exactly isosceles right angle triangle? First of all, we have given a right angle triangle. Let us we are assuming that right angle triangle is ABC, which is right angled at B. And once any two sides, that means the pair of perpendicular sides are congruent, then we can say that given right angle triangle is isosceles also. So it is now a isosceles right angle triangle whose congruent sides we have 7 cm and 7 cm. That means we have given here AB and BC both are 7 each. We have to evaluate the perimeter. So for that, let us try to evaluate firstly the hypotenuse of a given right angle triangle, that is the AC. So we are writing, suppose now in triangle ABC we have measures of an angle ABC is equals to a 90 degree, and one more thing we have, length of AB is equals to length of BC is equals to 7 cm. So once the given triangle is a right angle triangle, we are applying now Pythagoras theorem in it. So by Pythagoras theorem we have hypotenuse becomes now the AC, so that we are getting AC square equals to AB square plus BC square. Now the value of AB and BC is 7, so that AC square value we have 7 square plus 7 square. So AC square to be equals to 7 square is 49, 7 square is 49, so that we are getting 2 times a 49. To evaluate the value of AC, take square root on both sides. AC squares are square root, we have AC, while square root of we are getting 2 times 49. Once we separate out the square root, so that the value of AC we are getting 49 the square root is 7, root 2 as it is. So the value of AC is 7 times root 2 centimeter. Now to evaluate the perimeter of a given triangle, we have ABC. What is mean by the perimeter? Sum of all sides. That means we have now AB plus BC plus AC. Value of AB is 7, BC is 7 and AC is 7 times root 2. So that 7 plus 7 is 14. We are getting 14 plus 7 times root 2. So the perimeter of a given triangle we have as a 14 plus 7 times root of 2. We may take 7 common, so 7 2s becomes 14, so that we are getting 7 into 2 plus root of 2, that much centimeter be the perimeter of a required triangle. Look at now the question number 4. We have solved the following questions, challenging questions, 4 marks each question. As shown in the figure, LK equals to 6 times root 2, then MK equals to, LK equals to and MN equals to. That means here we have to evaluate for MK, next to it ML, next to it MN. So what shall we have to do? Look at firstly the given data. We have given here LK equals to 6 times root 2. So look at the triangle. We are writing in triangle MLK we have an angle MLK equals to 90 degree and the other angle MKL equals to 30 degree. So once the sum of all angles of a triangle equals to 180 degree, so that the value of an angle LMK is equal to 90 plus 30 we have 120, 180 minus 120 we are getting 60 degree. So that here we can write now the triangle MLK is 30 degree, 60 degree and 90 degree triangle. So look at now, once we have given here LK is 6 times root 2 and angle LMK we are getting 60 degree. So we well known for a 30, 60, 90 degree triangle, the side opposite to 60 degree angle is we have the LK, and which is equals to we have root 3 by 2 times the hypotenuse of triangle MLK, we have the MK. Try to replace by their value. As per the given data, LK equals to 6 times root 2, that to be equals to we have root 3 divided by 2 into MK. Now to evaluate the value of MK, try to shift root 3 divided by 2 from RHS to LHS, so that we are getting 6 into root of 2 into 2 whole divided by we have root 3, and it is a value of MK. Try to simplify now given numerical expression. We can write at start 6 as a 2 into 3 into we have root 2 into 2 as it is whole divided by root 3. Now we can write that 3 from numerator as a root 3 into root 3 into root 2 into 2 whole divided by root of 3 as it is. Now look ahead, root 3 from numerator denominator getting cancelled. 2 into 2 we have a 4, while root 3 into root 2 we have 3 2s are 6 under square root. So the value of MK we are getting 4 times root 6. So let's look at the figure now. We have MK value 4 times root of 6. Now MK, once we have 4 times root 6, we have to evaluate for the ML. Look at the ML. ML be the 30 degree opposite side for a same triangle. So that now we are having in triangle MLK, the opposite side of 30 degree angle which is ML, and that is equals to we have half of the hypotenuse, that is MK. So that 1 by 2 into we are having value of MK is 4 times root 6. Now 2 1s are 2, 2 2s are we have a 4. So that the value of ML we are getting 2 times root of 6. So look at the figure again. We are having the value of ML, that to be equals to 2 times root 6. So value of ML we have now. Try to evaluate for the MN. So for evaluating the MN, look at the MN. MN be the side of a triangle MKN. So that I am writing here in triangle MKN, we have an angle MKN is equal to 90 degree. As per the given, we have an angle that is MNK, that is equals to 45 degree. Once the sum of all angles of a triangle is equals to 180 degree, so the value of remaining angle, that is MN, we have an angle M, so NMK, that to be equals to 180 minus 90 plus 45 is 135, we are getting 45 degree. So that here we can write now the triangle MKN is 45, 45, 90 degree triangle. So the pair of opposite sides of 45 degree angle are now 1 upon root 2 times the hypotenuse. Look at the opposite sides of 45 degree angle. We have NK and we have the MK. So that we can write now MK is equals to we have NK is equals to 1 upon root 2 times the hypotenuse. Hypotenuse we have the MN. Now once we consider here MK to be equals to a 1 upon root 2 times the MN, because we are having the value of MN here. So we have the value of MK here, that is 4 times root 6. So 4 times root of 6 is equals to 1 upon root 2 into mn. Once we shift the root 2 from RHS to LHS to evaluate the value of mn, we are getting 4 times root 6 into root 2, that to be equals to mn, so that we can able to write now the mn value is, we have a 4 into root 6 into root 2, 6 2s are, we have a 12 under square root. So let's try to simplify furthermore. We have mn to be equals to now 4 into root of 12, we can write 4 3s are 12. Once we take 4 outside the square root, we have mn value to be equals to 4 into square root of 2, square root of 4 is 2 into root of 3. Now 4 2s are, we have a 8. So the value of mn, we are getting 8 times root of 3. Hence we have here all 3 sub-question. Value of mn we have 8 times root 3. So here we have all 4 questions from the chapter 2nd, Pythagoras theorem. Those all questions are from question bank provided by Maharashtra State Board. Now today we will stop here. During the next lecture we are going to start with the chapter 3, that is circle. Questions again from question bank provided by Maharashtra State Board. Thank you.